Every word you send to a language model costs money and processing time. When you stack system instructions, few-shot examples, and user history into a single massive prompt, you are quietly burning through your API budget and bogging down your application's response times. To fix this, we're going to use the Token-Budget-Negotiator. This tool systematically strips dead weight from your existing prompts while ensuring the final output quality stays right where you need it. Before we start, you need two things installed on your machine: Python 3.11 or higher, and a local model runner like Ollama to act as our evaluator. Eliminating prompt bloat allows you to scale AI applications while keeping per-request costs low and response times fast. Step 1 is making sure our evaluator is online. Run the check Ollama command in your terminal to verify your local language model is awake and ready to score our prompts. Now we need to format our input. Take your standard text prompt and convert it into a YAML file, breaking the text into isolated, named categories. This diagram shows exactly how your monolith of text breaks apart into distinct tiers, like system, few-shot, context, and instruction. You must assign a numerical priority to each of these segments. This priority score tells the tool exactly which sections to test for removal first. Do not just paste a wall of unstructured text here. The tool relies entirely on these rigid boundary definitions to function. Without them, the process will fail. With the YAML file formatted, run the analyze command to see exactly how many tokens your original prompt is consuming. This terminal breakdown shows the token allocation percentage for each section of your prompt. You can quickly see which categories are hoarding the largest share of your budget. Pinning down this exact numerical baseline is required. We have to know our starting footprint before we can accurately measure any automated reductions. Now we move to the optimization phase, which uses a process called greedy ablation. This is a targeted loop that takes your lowest priority section and attempts to delete it entirely. Notice this block detach and route to the central model judge. It tests the truncated prompt against a rubric, assigning a numerical grade. If the remaining prompt passes your threshold, the block goes to the discard bin. If it fails, it rebounds. Because of this strict pass-fail mechanism, you are guaranteed to walk away with a smaller token footprint without breaking the actual logic of your prompt. Let's put that theory into practice. In your terminal, run the negotiate command and point it at your newly formatted YAML file to start the loop. You will need to set the -t or quality threshold flag. This tells the tool the minimum percentage of the original prompt's performance it must maintain to consider a test successful. If you are running a smaller local judge, it's best to set this threshold somewhere between 80 and 90%. This gives the model enough room to absorb natural scoring variance. You'll also configure a savings target. This parameter acts as a finish line, forcing the loop to terminate the exact moment it hits your specified token reduction goal. Local scoring loops take time to complete. While the gears turn in the background, the tool is silently running through dozens of combinations, so you don't have to test them manually. Once the loop finishes, the terminal will print a success message confirming the ablation is complete and that your results have been compiled into a new document. Open that result.json file. Inside, you will find your final optimized prompt text alongside the operational metadata for the run. This chart shows the massive original token count next to the minimized optimized count. You can see exactly how much excess data was successfully dropped. If you check the metadata, it also displays the elapsed wall clock time and the precise number of scoring calls the API made to reach that result. Deploying this verified, reduced prompt into your live application lowers per-request costs and improves latency for your end users. We started with a massive, bloated input and methodically stripped it down into a highly efficient asset, preserving all of its core functional power. If you want to speed this process up and bypass local hardware entirely, you can route the scoring mechanism through an OpenRouter API key to leverage faster, cloud-based models. For a more advanced workflow, the negotiator can even operate directly inside AI coding agents like Claude Code, hooking in via an MCP server to optimize prompts mid-session. This automated pipeline provides a repeatable method for justifying every token in your prompt through measurable performance data.